Today we're going to talk about Pascal's triangle. Now, why Pascal's triangle is like so cool, and why we made a whole lesson just to talk about this funky looking triangle was because most mathematicians look at this, they don't see all these black numbers, but what they see are the combinations. For example, the ones 0, choose 0, not very interesting. This one, that's 1, choose 1. This one, 2, choose 2. You can go on and on and on in this diagonal. 3, choose 3, the same numbers top and bottom. Then there's 4, choose 4, and 5, choose 5. Down there on the board. I can do the same thing over here. Let's see, you just have 0 on the bottom. Just choose 0 objects, any out of X objects. There's still one way to do that, just do nothing. Not 1, choose 0. 2, choose 0. This is 3, choose 0. 4, choose 0. And again, down over here we have 5, choose 0. So back. And again, ones are very interesting, but let's look at these middle numbers. So 2, 3, 3, 4, 6, 4, 5, 10, 5, 10, 5. Well, 2, that's 2, choose 1. Also, don't bother memorizing all these. It's really hard to, if you think of it that way. Because, I mean, here's the thing. If you really know this really well, you can build this whenever you want if you really know everything. And 2, choose 2. That's also, 3 is 3, choose 2. 6, let's see, get 4, choose 2. Here we have 5, choose 2. Over here, let's see where's, okay. Over here, let's see what we got here. 4, that's 4, choose 3. 10 is 5, choose 3, that is. And finally, 5 is 5, choose 4. Okay, now I got this whole triangle, but you might say, that's not very useful. I mean, we could just compute these like usual instead of building a whole triangle to find all these combinations. Well, here's the thing. I'm going to tell you a couple patterns in Pascal's triangle. Well, first, the pattern that we use to build a triangle, we call this Pascal's identity. I'll write down Pascal's identity for you. Pascal's identity means n choose r plus n choose r plus 1 always equals n plus 1 choose r plus 1. Okay, you got that? You'd have to take my word for it, but a fun challenge, try proving this on your own if you want to, but that's optional. Now, again, give you a little lightning round. We're going to discuss 4 main patterns in Pascal's triangle. Okay, for pattern number 1, we'll take the sum, we'll add all the numbers in each row of Pascal's triangle. 1, not very interesting. 1 plus 1, 2. 1 plus 2 plus 1, 4. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 1 is 8. Sound like a little interesting, huh? 1 plus 4, 5. Plus 6, 11. Plus the 4 and 1, that's 5. 11 plus 5 is 16. I think you know what to expect down here. 1 plus 5 is 6. Plus 2 is 2 tens. That's 26. And 1, 5, and 1, 32. We're just counting out powers of 2 just by adding the rows of Pascal's triangle. You know what's next? 2 to the 6th power. Okay, on pattern number 2 in the lightning round. We'll skip the first row. We'll take a little alternating sum, plus minus, plus minus, plus minus between these. Plus 1 minus 1, 0. Plus 1 minus 2, that's negative 1. Add on 1, you get 0. Plus 1 minus 3, that's negative 2. Plus 3, you get positive 1. Minus 1, you get 0. 1 minus 4 plus 6 minus 4 plus 1, you gotta take my word for it, that's 0. Plus 1 minus 5 plus 10 minus 10 plus 5 minus 1. 1's cancel, 10's cancel, 5's cancel, and you are left with 0. The zeros aren't very interesting, but what is interesting is that we always get zeros. Again, all these patterns means a deeper mathematical meaning, just like how this 1 plus 1 is 2, Pascal's identity. There's a deeper mathematical meaning for every single kind of pattern that we are discussing. Pattern number 3, pattern number 3, again, skip the first row. Let's look at these two. We're gonna squeeze them together. 1 plus 1, 11. Why do we care about 11? I guess it's prime, but not very interesting. Squeeze these together. 121. That's 11 squared. Squeeze these together. You get 1,331, and you can use your calculator if you want, but that is 11 cubed. Now let's squeeze this row together. We get 14,641. Again, you can use your calculator, but again, take my word for it. That is 1124. What about this next row? Here we get a 5-digit number, but down here, that's an 8-digit number, When we multiply a 5-digit number by 11, we're probably gonna get a 6-digit number, Well, we might get a 7-digit number, but we're definitely not gonna get an 8-digit number. So it looks like this only works down here. Actually, it doesn't. Try seeing what 11 to the 5th power is, but just glancing at this row of Pascal's triangle, using what you already know about combinations and everything. Try looking at what is 11 to the 5th power. Leave that as an extra challenge for you. But anyways, last pattern in our lightning round. Well, we've been dealing with rows so far, like squeezing them together and everything. Now let's look at some diagonals. 1 plus 2 is 3. 1 plus 2 plus 3 plus 4 is 10. Let's try to do a little different diagonal. 1 plus 3 plus 6 is 10 again. We can go the other way as well. 1 plus 2 plus 3 plus 4 equals 10. And in the middle, 2 plus 3 plus 4, we already discussed that one. So, you get my picture. There's a whole bunch of patterns. Again, homework, try to prove all of these on your own. And then, listing out a few more rows, look for a couple patterns yourself.